So we sort of looked at this loan size by loan grade. Okay, so when we did this cat plot, right, we are sort of plotting the average loan size by loan grade, right? And you see this weird thing on top of each bar, right? So what do they represent, right? Or what do we mean, or what is this plot telling us? Okay, so let's go back to this thing. Okay, so this is the same plot, but it's a little bit more. It's a smaller in size. So we are plotting that same plot here. Okay, so let's do that. And you see this term called confidence interval equals 95. Okay, so what is confidence interval? Okay, so the best way to think about this is that let's say you have an employee, you work at a company and you have that company has like say 1,000 employees. Okay, and you want to sort of get a good estimate of what the average height is within the place where you work, right? Of the entire employee base, right? How do you go about that? You can technically sort of say, okay, 1,000 of you get here. I'm going to measure each one of you and see whether, and then I'm going to collect the data and estimate the average height, right? Or I can take a representative sample. Okay, so let's say I take a sample of 20 people. Okay, and I calculate their height, and I can sort of say that, based on this sample, I think the population height, okay, is going to be X. Okay, whatever that sample size height is going to tell you, right? And that is the nature of your work, likely in every instance, right? So every time you're going to be dealing with a data set, it's going to be a sample data, right? You are never truly going to have a population data which basically is going to cover all the customers you're going to ever encounter, or all the defective parts you will ever encounter, if whatever you're measuring, right? So you're always going to be dealing with sample data, and you're going to use that sample data to infer on that population, right? You're going to make predictions on that population based on this sample data, right? That's the nature of work. And not only most of the time you will not have access to population data because it's prohibitively expensive to actually collect and measure everything you want to measure, but also it's going to be very time consuming and so on. So plus you might not have the ability to analyze that kind of data, right? So you're going to be dealing with sample data. So, and you're going to infer, right? So you're going to infer that based on this, in this case, for example, right, you have this loan data set, right? And you're trying to sort of make a prediction, say that, okay, what is the average loan size by loan grade, right? You're trying to sort of estimate what the population loan size looks like by loan grade, right? And let's say you were able to collect 100 different samples. You have a huge population data set, right? And it's you want to get a taste of what your population characteristic looks like, right? Or let's say you will have data you're going to collect at different intervals. You don't have access to the entire population, so you're going to pull 100 different times a small sample of data, right? And you're going to do the same plotting, for example, right? When you are going to estimate the mean by loan grade, when you say 95% confidence interval, what that truly means is that 95% of those 100 samples you're going to pull, 95% of those sample is going to be able to capture the true population mean, okay? And that 95% band is represented by this line, okay? So what this band is telling you is that 95% of the sample you're going to collect, or you're going to pull from this population data, 95% of them is going to capture the true population mean. Only 5 out of 100 sample data you're going to collect will not have the true population mean, right? So only 5 of that sample you're going to collect, 5 samples you're going to collect, could have a mean here, okay, below this band, or could have a mean above that band, okay? which is going to tell us that the population mean is actually not within this band, it is beyond these bands. Okay, that's basically confidence interval. Okay, if you want to capture, if you want to be more certain that I want to have a band which is going to capture the population mean 99% of the time, then of course you're going to have a taller band, right? So you're going to have a band which starts here and it's going to go all the way here, and you're going to be more certain that 90, because you're going to, what you're trying to what you're going to try what you're trying to infer is that when you pull 99 samples out of 99 samples out of 100 are going to have the true estimate of the population mean. Okay, and so why do we have a longer band, the confidence interval in some cases, for example AAA, versus a very short interval in for say loan grade B, right? And that is because of the sample size, right? And so this is let's say you have this loan grade AAA, and you take this data, right, and you have you estimate the sample mean for each loan grade, right? This is the z-score which corresponds to say 95% or 99% confidence interval. So 95% confidence interval, the z-score is 1.96. 99% is 2.576. We have sort of covered that before. This is just a reiteration of what we have done in the past, right? So of course 99% confidence interval is going to have a larger band, and hence it has a bigger value, because you want to be more certain in that case that your sample you collected is a true representation of the population mean confidence or population mean, and is able to capture in that confidence interval band, right? S over square root of n is the standard error, okay, associated with that sample mean. Okay, and quite naturally, right, the bigger the sample size you're going to collect, okay, you're going to have a much better estimate of the population mean, which is natural, right? So let's say you're measuring the height data in your company, right, in your employer, and instead of collecting say a sample of 20 people, if you're able to collect a sample of 200 people, you're going to be more closer to the true population height as opposed to when you're collecting a sample of 20. Okay, that's pretty natural. Okay, so the bigger the sample size is, the smaller this term gets, and the smaller the band gets, right, that confidence interval band, right? So around the sample mean, this for 95%, this is 1.96. This gets smaller, okay, as the sample size gets bigger, the n gets bigger, right? And that's why you have a smaller band in some cases, because if you were to look at this loan grade entry, right, you see that AAA has only 6 entries, whereas B has 3,000, right? So 3,000 entries, this becomes a much smaller term, and that's why you have a smaller band here, right? And we can sort of see that with another thing. I'm not sure whether this is going to be very clear. You can also manually calculate that, okay? And we are going to do this APR plotting, APR by loan grade, right? And we can say, okay, what is the this is the same set of loan grade numbers you have based on the sample we have, right? So you have 6 entries of AAA and 3,000 some odd entries for B and so on, right? So you're going to put that to, you're going to assign that to a variable n, right? Okay, let's do that. Okay, and we are going to calculate x, okay, which is the sample mean. Okay, so we are going to calculate loan grade by, okay, so let's do that. Okay, let's do that separately. Okay, so we did calculate all this sample mean. So if you look at it, APR AAA is around this, which is 6.5. Okay, that's the top of that bar. E is 27.34, which is around here, which sort of makes sense. Okay, so we do calculate the x. Okay, and then we calculate the standard deviation using this thing by each. Okay, so let's calculate the x. Okay, and then we can calculate the band. Okay, so as you can see, the top of that band and the bottom of that band. Okay, so the AAA has a range of 6.17 to 6.86. Okay, which I think this bar is able to capture that. E has a range of 27.14 to 27.54. So pretty tight bands in all cases, right? And that is because which term is basically a, I think it is because the standard deviation, okay, the S is not very, it does not vary as much. Okay, let's see that. Okay, so let's see the standard deviations in most cases. Okay, so it's pretty, we see that it does vary, but it varies off of a bigger number in E versus a very small number in this case, right? So if you do S over square root of n, it becomes a very small term, and that's why you don't see a lot of variation in terms of the confidence interval band. Okay, so I hope this is clear. I think confidence intervals will be you'll encounter them over and over again in a lot of the statistical side of data analysis you're going to be doing. So I think it's a good idea to sort of get a feel of what they mean.